we take a look at some of the most amazing and strangest new drones. Now, there are quite a few research projects out there which can overcome rotor failure, but this latest development from ETH Zurich can actually still perform flight maneuvers even after losing one motor. This is done with onboard sensors and a vision system which ditches reliance on GPS. Two types of visual inputs are compared with vision-based estimation, standard frames, and events. As a result, the drone can actually fly in very tight areas without losing control. Now, landing may still be a little bit of a challenge, but theoretically it could cut its motors off just before hitting the ground. And it could be a very excellent safety feature in next-generation multi-rotors. At number 6, and it's the weird Smellicopter. Now, there have been many technologies developed for navigation, but this particular drone is definitely weird. It utilizes an antenna from a live moth to navigate its way towards a smell. This means that it can sense and avoid obstacles as it travels through the air. One antenna can consist of hundreds of tiny hairs, which detect these smells, and one molecule can trigger a cellular response. So researchers hooked up electrical wires and averaged out cell signal. Combined with infrared sensors, the drone can be used to detect explosives, gas leaks, and even imminent human swats. We get to number 5, which is basically a flying ornament titled the Lemur. Drones can now supposedly break and enter without being subjected to the criminal code. Built by drone nerds and the Las Vegas SWAT team, this particular drone can scale stairs, open doors, and even perform two-way communication for negotiation. But its most frightening tool is probably its glass breaker, which can spin up to 30,000 RPM, and this allows it to basically go through anything. The multicopter also features a carbon structure along with a payload bay, but luckily this will never make it to the open market, and it will only be available to SWAT teams. At number 4, the Anafi AI. Now, there are quite a few innovative drones on the market, so it's kind of hard to cover them all, but this particular drone from Parrot is truly next level. It has a basic Wi-Fi setup, but it will switch automatically to an encrypted 4G signal if the signal degrades. It also has an obstacle avoidance system which utilizes stereoscopic cameras for autonomous flight. But this type of feature is quickly becoming the standard for higher-end drones. Nevertheless, it does feature a 48 megapixel camera which is affixed to a 6-axis stabilized gimbal. This allows it to tilt 180 degrees vertically. But all of this will probably be very expensive, as the drone will likely start at around $7,000. At number 3, and it's a bit of a work in progress project which is titled the Dragon. Now, the University of Tokyo has been working on deformable multi-rotor systems for several years now, but their latest variants are very impressive, and they can now plan and calculate maneuvers beforehand. Now, this is easier said than done because the Dragon platform is actually doing all this in 3 dimensions. So joint torque, thrust force, and even kinematics are all precisely calculated and controlled. Now, these transforming multi-rotor systems can be a part of the next generation of drones. But the problem right now is that they have very limited flight times. But better algorithm design and more efficient power sources will make this technology even more feasible. Ultimately, it will be very interesting to see advancements in this Dragon platform, and I think the team is going to make something really unique in the future. At number 2, the Cyclo-Car. Now, as most of you know, this particular concept is nothing new, but a Russian company is trying to make this contraption into a fully manned craft. It features a number of variable pitch blades in fast rotating barrels. Each blade constantly changes its pitch as the barrel spins, meaning the craft can vector its thrust almost instantaneously without changing motor RPM. The team plans to utilize a hybrid propulsion system, which incorporates an electric drive and a combustion generator. Eventually, it will carry 6 passengers up to 310 miles at 150 miles per hour. Now, it's not quite at the final stage, and the team is still working on several subscale prototypes, so the project is still a few years away. So the future of drone technology will probably hinge on better power sources, morphing capabilities, and possibly swarm integration. This also brings us to number 1, which is a collaborative drone project. Now, theoretically, these drones can be used for sensing, constructing, or even carrying large payloads. Georgia Institute of Technology has already utilized 4 drones, which can communicate with each other while in autonomous flight. Doing so allows them to coordinate thrust and orientation so that they can fly as one unit. The system can also measure the load's weight, so in theory, the swarm could call for more drones if the load is too heavy. AI swarm integration is very intriguing, and it could be a very pivotal point for the next generation of drones. But I would also like to know what you think about all these technologies. So please leave a comment, like the video if you enjoyed it, and also make sure to subscribe.